Factorization for class 9. Factorization is a process of expressing an expression as a product of two or more expressions. To understand this, let us consider a number example. The number 12 can be written as a product of two numbers, that is 4 into 3, 6 into 2 and 12 into 1. The same number can also be written as 1 into 2 into 2 into 3. That is, you see that the number 12 is broken down into smaller numbers, which when you multiply together you get the same number. In the similar way, if you have an expression, say x square minus y square, we can write this as a product of two expressions, that is x minus y and x plus y. That is breaking down this expression as x minus y and x plus y, which when you multiply together you will get x square minus y square. Now the numbers which occur in the product are called to be as the factors of the number. That is 4, 3, 2, 6 and 12 are said to be factors of 12 because they divide this number completely. That is, if you have 12 divided by 4, I get 3. It means when this is divided, the remainder is 0. In the similar way, the expressions that occur in the product are also said to be the factor of this expression x square minus y square. In this topic, there will be 5 methods that we will be seeing how to factorize an expression. In today's video though, we will be taking 3 methods to factorize an expression. Let us take the first method. The first one is said to be by factorization by taking out a common factor. Let us take examples from exercise 4a. The first one let us take is the third one, that is 27x cube y cube minus 45x raised to 4 y square. Now here there are 3 terms, that is, one is a number term, one is a variable in terms of x and the other one is a variable in terms of y. We are taking the common factor. Between 27 and 45, you find the highest common factor, which is 9. The next one is to take a common factor from the variable x. To choose that, you choose the variable with the lowest degree. So between x cube and x raised to 4, the lowest degree is x cube. And for the y variable, the lowest degree is y square. So what remains inside is 3y minus 5x. So therefore we see that this expression is factorized as 9x cube y square into 3y minus 5x. Let us consider another problem, problem number 9. You have x plus y the whole cube minus 3x square y x plus y. In this term, you see that there are 2 terms which are common. One is x and the other one is the entire bracket x plus y. So when you are taking it common, we see that x is over here also. So the one with the lowest degree, that is x, and the entire bracket with the lowest degree again is x plus y. The degree over here is 1. So what remains inside is x plus y the whole square minus 3xy, since 1x is taken out from here. Now over here you will be using the expansion of a plus b the whole square, which you have learned in the previous topic. So this is x into x plus y, and this will be x square plus y square plus 2xy minus 3xy, which will be x into x plus y, x square plus y square minus xy. So this expression is again reduced as a product of here 3 terms or 3 expressions. Next method here is factorization by grouping. To understand this, first let us take an example with 4 terms. That is from the same exercise, problem number 12. A cube b minus a square b plus 5ab minus 5b. Now, for 4 terms, there is 1, 2, 3 and 4. For grouping, you group these 4 terms into 2 groups and there should be 2 terms in each group. So let us consider the first and the second term and this one. So there are two groups. In these two groups, now you take out a common factor. In the first group, what is the common factor? There is a square, which is with the lowest degree, and there is b. So a square and b. So what remains inside is a minus 1. From the second one, I have 5 and b, which is common. So what remains inside is a minus 1. So now we have reduced to two terms. Once you have reduced to two terms, you again check if there is any other common factor, which is b, and a minus 1, a minus 1. So b and a minus 1 will be, so you have a square plus 5. Now whilst grouping, you could have taken the first and the third term also, or second and the last. You would also get the same answer. For example, first you group it. So a cube b plus 5ab, grouping the first and the third term as one group, and in the next one a square minus 5b, a square b. So you have from the first group a and b common, so this will be a square plus 5, and from the next two groups, from the next group there is a negative sign common and there is b that is common, so you have a square plus 5. So which will be, from this again there is a square plus 5 common and b that is common, so you have b a square plus 5, and you have a minus 1, which is one and the same. Let us take another example. This will be with three terms. For three terms, let us take an example. The 15th problem. I have 4a minus 1 the whole square minus 8a plus 2. Now when there are three terms, there are two ways to go about this problem. You're using the other two terms which are not in the bracket, you check if you can obtain the same bracket by taking a common factor. If that is not possible, then you open up the bracket. But in this case, you see that from the other two numbers, you can obtain the same bracket by taking a negative 2 common. So you have 4a minus 1 the whole square. Taking a negative 2 common, I get 4a minus 1. Now since there are two terms, what is the next factor? It is 4a minus 1. So that is 4a minus 1 is 4a minus 1, one term of that, and minus 2, which will be 4a minus 1, 4a minus 3. Let us take another example with the same. Let's take another example. You have problem number 23. A cube plus ab 1 minus 2a minus 2b square. Now in this again there are these three terms. Now here you cannot obtain 1 minus 2a from the remaining two, because there is nothing common in the first nor the last term. So what is the second method is you directly open up the bracket over here. So I have a cube plus ab minus 2a square b minus 2b square. So now these are now this is 4 terms expression. So 4 term expression is you group them into two terms, into two groups. So you have it as a into a square plus b minus, here negative as negative sign is common, along with 2 and b. So I have a square minus plus b. Again, which is the factor that is common? You have a square plus b. So that will be a square plus b into a minus 2b. Let us consider another example with two terms. When you have two terms in an algebraic expression, you directly open up the brackets. So you have here as a square plus ab minus ac minus bc. So now you have an algebraic expression with 4 terms. So you repeat the same process again. So from the first group, a is common, and from the second group, negative c is common to give you a plus b. Again from this, you see that the bracket a plus b is common, so what has remained is a minus c. The next method is difference of two squares. Note that taking out a common factor and grouping, we consider it as 1. Now difference of two squares, we make use of the identity, that is a square minus b square is equal to a minus b and a plus b. This method is used when in an algebraic expression there are minimum two square terms wherein one has a negative sign. Let us take a very simple example from exercise 4b. The first problem, I have x square minus 49. We check if this number can be written in terms of square, which can be written as x square minus 7 square. Therefore, this is the expression a square minus b square, so I can write it as x minus 7 and x plus 7. Note that the same thing could have been asked as 49 minus x square, so I would have written as 7 square minus x square. And now this can be written as 7 minus x and 7 plus x. Note that the change in the position of the numbers changes the answer as well here. Let us consider another one. Let us say problem number 22, the second one. 674 the whole square minus 326 the whole square. In this one you have to find the value of this using this identity. How would you do it? This will be 674 minus 326 into 674 plus 326, which will be equal to 843, and this will be 1000, which is equal to 348000. You see that using this identity, your calculation becomes much more simpler. Consider another problem. Here you have two terms which are having squares, and there is one which has a negative sign. So let us check if the terms with squares has the coefficient which are also the squares of any numbers, which here is 9 and 4, which are the squares of 3 and 2. So then the next step, we write them in the square form. So that will be 3 into b plus 2a the whole square minus 2a the whole square. Now this entire term is taken as a and this will be taken as b. So you have this as 3 into b plus 2a minus 2a, that is a minus b, and 3 times b plus 2a plus 2a, that will be a plus b. So opening up the brackets, I get 3b plus 6a minus 2a, and this will be 3b plus 6a plus 2a, which is 3b plus 4a, and this one will be 3b plus 80. Next example is 2x4 minus 32. Note that 2 and 32 are not the squares of any number, so you first thing you do is you take out a common factor. So that will be 2 times x squared minus x raised to 4 minus 16. Now 4 is a multiple of 2, so you could write it as x square the whole square minus 4 square. Now this is a and this is b, so you can write it as x square minus 4 and x square plus 4. Now note that you can use the identity again only for when there is a difference, that is when there is a negative sign here. So that will be 2 times 4 can be written, it is a square of a natural number. So therefore I can write it as x minus 2 and x plus 2, and x square plus 4 will remain the same. Let us consider another example. Problem number 20. You have x minus x square minus y plus y square. If in this one we have used taking out a common factor, in this we will be using grouping method. So first thing is, when there are 4 terms, you will group them in such a way that in one group there are the square terms with one having a negative sign. So that will be x minus y and the next group will be of x square plus y. X square plus y square. Taking out a negative sign out, I have x square minus y square. And now using the identity, this will be x minus y, x minus y, x plus y. Now you take a common factor, that is x minus y is the common factor. So what remains is 1 minus x plus y, which when I multiply inside I get x minus y. The next examples that we are going to take we will be using the expansion of a plus b the whole square, which is nothing but a square plus 2ab plus b square, and if there is a negative sign here, there will be the negative sign for the middle term. Let us consider the 17th problem of the exercise. You have x square minus y square plus 2yz minus z square. Now here you see that there are minimum 2 square terms. We will check the one which is a product of 2 variables here. Now these 2 variables can also be same. You see that is the same as the expansion here of a plus b. Only thing, in place of ab there is yz. So to complete the expansion, which terms do you require? You will require terms of y square and z square, which are already here. So you group them together. So you have x square minus, now this is one group, so from which I will take a negative sign common. So I have y square minus 2yz plus z square. So you have y square minus 2yz plus z square is nothing but the expansion of y minus z the whole square. When the middle term has a negative sign, it is going to be a minus b. So now you use the identity of a square minus b square, which will be x minus y minus z and x plus y minus z. Opening up the bracket further, I have x minus y plus z, and this will be x plus y minus z. In the similar way, let us take another example. Problem number 29. 4x square minus 12ax minus y square minus z square minus 2yz plus 9a square. Now here you see that there are 4 square terms, but let us look at the terms which has a product of 2 variables. Again there will be of the expansions term. So now since there are 4 terms, it means there will be 2 groups and there will be 2 expansion terms. So here the first expansion will be between a and x. So you group those terms together. So that will be 4x square minus 12ax plus 9a square. From the next one, this is the next group, from which we can first only take a negative sign common. So I have negative y square plus z square plus 2yz. Now here 4x square minus 12ax plus 9a square is nothing but the expansion of 2x minus 3a the whole square. You always check which it is by taking the first term and the last term, the square terms. And the sign depends, whichever is the sign of the middle term is the sign that you take here. You can recheck. 4x square plus 9a square minus 2 into 2 into 3 is 12. This will be y plus z the whole square. Now since this is the difference of 2 squares, you use the identity to get 2x minus 3a plus y plus z into 2x minus 3a minus y minus z. I have already multiplied this negative sign inside. That's it. We'll take another 2 examples, that is problem number 24 and problem number 26. Let's solve problem number 24 first. Here also we'll be using the same expansion, wherein here now 9x raised to 4, and here the middle term here is 12x. Since the last term is a square of a number, so this will be x into that number. So here I will group them as x square plus 12x plus 6 plus 36, taking out the negative sign common. So this Now since 4 is a multiple of 2, it can be written as 9x square, the whole square. And this will be x plus 6 the whole square. X plus 6 the whole square is this expansion. So this will be 3x square the whole square minus x plus 6 the whole square. Which now when you use the identity, I will get 3x square minus x plus 6, and this will be 3x square plus x plus 6, which will be 3x square minus x minus 6 and 3x square plus x plus 6. Similarly, in this case now, when there is a expression with the highest power as 4 and there are only 3 terms, we look at the first and the last term. The first term can be written in terms of square as well as the last number term, which can be expressed as 3 square. So what I'll write it as x square the whole square plus 5x square plus 3 square. To understand better, let say x square be equal to a. So I have this as a square plus 5a plus say 9. Now this, let us check if this is the expansion here. A plus 3 the whole square is equal to a square plus 6a plus 9. We see that these things are almost the same, both the expression, except for this 5 and 6 here. So it means let us add for in this types of terms, when there are 3 terms and the highest power is 4 with a number and x term missing, we will be adding to this one a and subtract an a. So I have a square plus 5a plus 9. So I add a and subtract a so that it becomes 6 here. So taking the positive one inside, I have 6a plus 9 minus a. Now a square plus 6a plus 9 is nothing but a plus 3 the whole square, and a remains. Resubstituting here, I get x square plus 3 the whole square minus x square. This will be the identity, and I have x square plus 3 minus x square plus 3 plus x. Here is another example, problem number 31. You have to express both this expression as a difference of 2 squares, meaning you have to write these as a square minus b square. But to write a square minus b square, we have to write it as a minus b. But you see that there are 3 terms here, so you have to make sure that you put them into 2 groups of a and b. How do you do that? Look at the terms which have the same sign. There is x square, which is the positive sign, and there is negative 15, which is same in the next bracket also. So let us group those as the same one. So x square minus 15 as one group plus 8x, and in the next one x square minus 15 minus 8x. So now this will be considered as a, this will be considered as b. Similarly here a and b. So once you have a minus b and a plus b, so therefore you can express this as x square minus 15 the whole square minus 8x the whole square. That's it. Based on the methods, that is the 3 methods, which was taking out the common factor, grouping, and difference between 2 squares, try to solve exercise problems from exercise 4a and 4b from R.S. Agarwal. Thank you.